Good morning, students. Today we are going to start very important topic in chemistry, that is molecules and covalent bonds. So concentrate yourself. We are going to start. Molecules and compounds. When two or more atoms are chemically bonded together, a molecule is formed. A molecule is a group of the atoms chemically bonded together. Most non-metallic elements are found in the molecular form. That is, two or more of the same type of the atoms are bonded together. Examples are iodine molecules. I2 contains two iodine molecules. Sulfur molecules. S8 contains 8 sulfur atoms. If a molecule is made up of the atoms of the two or more different elements, a compound is formed. A compound is a substance made when two or more elements are joined together by a chemical reaction. For example, a molecule of the water, H2O, is made up of two elements, two atoms of the hydrogen and one atom of the oxygen. A molecule of the chloroform, formula is CHCl3, is made up of three elements, one atom of the carbon, one atom of the hydrogen, and three atoms of the chlorine. Next topic is covalent bonding. Covalent bonds are usually formed between atoms of the non-metals. A sharing of the electrons between two atoms allow both to achieve a stable noble gas configuration. If two atoms share one pair of the electrons, a single bond is formed. Two pairs of the electrons, a double bond is formed. Three pairs of the electrons, a triple bond is formed. Each atom contributes an equal number of the electrons for sharing. In the following examples, only the outermost shell is shown. The first example is hydrogen molecule. Electron configuration of H is 1. Each hydrogen atom contributes one electron for sharing. Two hydrogen atoms share one pair of the electrons so that each atom can achieve a stable noble gas configuration. A single bond is formed between the two hydrogen atoms. There is one electron in the outermost shell as well as in the outermost shell of the other hydrogen atom, and they will combine like this. So this diagram frequently come in the paper to draw. So do practice. Example number 2 is oxygen molecule. Electron configuration is 2,6. Each oxygen atom contributes 2 electrons for sharing. Two oxygen atoms share 2 pairs of the electrons so that each atom can achieve a stable noble gas configuration. A double bond is formed between the two oxygen atoms like this. Both oxygen atoms will contribute 2 electrons to gain electron configuration, noble gas configuration. And other example is here, that is nitrogen molecule. Electron configuration of nitrogen is 2,5. From here we can see nitrogen requires 3 electrons to achieve noble gas configuration. So that's why each nitrogen atom contributes 3 electrons for sharing. 2 nitrogen atoms share 3 pairs of the electrons so that each atom can achieve a stable noble gas configuration. A triple bond is formed between the 2 nitrogen atoms. Diagram representation is here. Each nitrogen atom will contribute 3 electrons to achieve noble gas configuration. Another example is here. Hydrogen chloride molecule. Electron configuration of chlorine is 287. From here we can see chlorine requires 1 electron to achieve noble gas configuration. So that's why each chlorine atom contributes 1 electron for sharing. Electron configuration of hydrogen is 1. From here we can see also hydrogen requires 1 electron to achieve noble gas configuration. So each hydrogen atom contributes 1 electron for sharing. 1 chlorine atom and 1 hydrogen atom share 1 pair of the electrons so that each atom can achieve a stable noble gas configuration. The chlorine atom achieves an electronic configuration, while each hydrogen atom achieves an electron configuration of helium. And here is the diagram representation. Each atom is contributing 1 electron to gain noble gas configuration. A single bond is formed between the hydrogen and the chlorine atoms. Another example is here, water molecule. Electron configuration of oxygen is 2,6. From here we can see oxygen requires 2 electrons to achieve noble gas configuration. So each oxygen atom contributes 2 electrons for sharing. Electron configuration of hydrogen is 1. From here we can see hydrogen requires 1 electron to achieve noble gas configuration. So that's why each hydrogen atom contributes 1 electron for sharing. Therefore, 2 hydrogen atoms are needed to contribute a total of the 2 electrons for sharing. Because oxygen is going to share 2 electrons, so that's why 2 hydrogens are required to contribute. 1 oxygen atom and 2 hydrogen atoms share 2 pairs of the electrons so that each atom can achieve a stable noble gas configuration. And here is the diagram representation. Oxygen is going to share 2 electrons and each of the hydrogen atom is going to share 1 electron. So here is the compound, that is water molecule. Another example is methane molecule. Electron configuration of carbon is 2,4. From here we can see carbon requires 4 electrons to achieve noble gas configuration. So each carbon atom contributes 4 electrons for sharing. Electron configuration of hydrogen is 1. From here we can see 1 electron is required by the hydrogen to achieve noble gas configuration. Each hydrogen atom contributes 1 electron for sharing. Because carbon is going to share 4 electrons, so that's why 4 hydrogen atoms are required. Therefore, 4 hydrogen atoms are needed to contribute a total of the 4 electrons for sharing. 1 carbon atom and 4 hydrogen atoms share 4 pairs of the electrons so that each atom can achieve a stable noble gas configuration. And here is the diagram representation. Carbon is going to share 4 electrons and each hydrogen atom is going to share 1 electron. So, methane molecule will be formed. Another example is carbon dioxide molecule. Electron configuration of carbon is 2,4. From here we can see carbon is required 4 electrons to achieve noble gas configuration. Each carbon atom contributes 4 electrons for sharing. Electron configuration of oxygen is 2,6. From here we can see oxygen atom required 2 electrons to achieve noble gas configuration. Each oxygen atom contributes 2 electrons for sharing. And from here we can see now 2 oxygen atoms are required to share 4 electrons with the carbon atoms. So therefore 2 oxygen atoms are needed to contribute a total of the 4 electrons for sharing. 1 carbon atom and 2 oxygen atoms share 4 pairs of the electrons so that each atom can achieve a stable noble gas configuration. 2 double bonds are formed between the carbon and the oxygen atom. Here is carbon that is going to share 4 electrons, and here are oxygen atoms. Each oxygen atom is going to share 2 electrons each. And this is the carbon dioxide molecule which is going to form. Here comes the properties of the covalent compounds. First property is covalent compounds have low melting and boiling points. Explanation for this point is the molecules are held together by weak van der Waals forces of the attraction. Very little energy is required to overcome these weak intermolecular forces. Second property is covalent compounds do not conduct electricity. Molecules in the covalent compounds do not carry charges. That is, there are no ions in the covalent compounds. That's why they do not conduct electricity. Next property is covalent compounds can dissolve in organic solvents but not in water. Explanation is covalent compound molecules are not readily hydrated by water molecules. Table summarizes the differences between the ionic and covalent compounds. This is very important question. This frequently come in the paper. Volatility of the ionic compounds are not volatile due to high melting and boiling points, whereas covalent compounds are volatile due to low melting and boiling points. Solubility of the ionic compounds are soluble in water but not soluble in organic solvents. For covalent compounds, soluble in organic solvents but not soluble in water. Electrical conductivity for ionic compounds is conduct electricity when molten or in aqueous solution. Electrical conductivity for covalent compounds do not conduct electricity. Here is a question. An element X has proton number 15 while element Y has proton number 17. Draw a dot and cross diagram to show all electrons in the molecule formed from X and Y. So the proton number of element X is 15, so electron configuration is 285. Each atom of the X contributes 3 electrons for sharing. This can be seen from here. Electron configuration of Y is 287 because proton number is 17. Each atom of Y contributes 1 electron for sharing. This can be seen from here. 1 X atom and 3 Y atoms share 3 pairs of the electrons so that each atom can achieve a stable noble gas configuration. 3 single bonds are formed between the X and Y. And here is the diagram. Because X element is going to share 3 electrons and each of Y is going to share 1 electron. And other question is, hot aluminium reacts vigorously with chlorine gas to form a compound which sublimes readily. A part is the compound a covalent or ionic compound? Explain your answer. Answer is covalent compound. Compounds that undergo sublimation have very weak intermolecular forces of the attraction between the molecules that are easily overcome. B requirement is give the formula of the compound formed. An aluminium atom has a configuration of 283 and the chlorine atom has a configuration of 287. Each aluminium contributes 3 electrons for sharing. Each chlorine atom contributes 1 electron for sharing. Therefore, one aluminium atom will share 3 pairs of the electrons with 3 atoms of the chlorine. The formula of the compound will be AlCl3. So this was the topic. Read it again very carefully. This is very important topic and make your notes. Thank you so much.